All right, so when it comes to coordinate geometry, let's look at the first part, the midpoint of a line. Okay, so the first, maybe just recapping, the midpoint of a line. So if I draw a line, let's say AB, and I want to find the midpoint given the coordinates, let's say I got 2, 5, and -5 and 1. Or let's say the other way around. Let's say this is 5 and 12. All right, so the midpoint of this line would be halfway, in which case I would be cutting the line into exactly two halves. To find the midpoint, what we do is we use the formula, take x1 from one of the coordinates plus x2 from the other coordinate, divided by 2, then take y1 from one of the coordinates plus y2 from the other coordinates divided by 2, and that would give you that coordinate over there. So in this case here, you would take 2 plus 5 divided by 2 and 5 plus 12 divided by 2. And how did I get that? Starting with this one, I'm going to label this x1, y1, and label this x2, y2. And so there we go. x1 ends up as 2, x2 ends up as 5, and then y1 ends up as 5, and y2 ends up as 12. We then divide it by 2, going exactly halfway. 2 plus 5 gets you 7. 7 divided by 2 is 3.5. And 5 plus 12 is 17. 17 divided by 2 is 8.5. And it's from A to B. That's the midpoint. Let's call it M. So this would be the coordinate of M. Let's try another one. Maybe you can try this one. So this one's going to be a negative gradient, but we're not calculating gradient. We're calculating the midpoint. So let's suppose this is -3 and 4. Cool. And let's say this is B, 5, and -6. Let's calculate the coordinate of M. Feel free to use a calculator as well. Press pause, try it. When you're done, press play. So the first thing I'm going to do is I'm going to add -3 and 5. All right, here we go. So this is going to become -3 plus 5 divided by 2, where this is x1 and this is x2. Then I'm going to take y1, which is 4, plus y2, which is -6, and divide it by 2. And this is going to become -3 plus 5 is 2. 2 divided by 2 is 1. 4 minus 6 is -2. -2 divided by 2 is -1. So yeah, that's going to be a midpoint, 1 and -1. Okay, so that's the midpoint formula done. Let's go to the next concept, which is the length of a line. All right, so still on the same topic of coordinate geometry, but the length of a line. So when I'm calculating and I want to find the length of a line, let's start with an example. Again, I'm given two coordinates, let's say 0 and 4, 9 and 15. Now I want to know, how long is this line? The first thing you notice is that if I create a 90-degree triangle, I can apply the concept of Pythagoras theorem, in which case I have a y value, an x value, and I can square it to get x squared plus y squared, and add it, and then square root it to get the value of how long, using Pythagoras theorem. Now, using that same idea, I've the formula for the length of a line as AB is actually equal to the difference in coordinates of the x components, in which case if I take x2 minus x1, and I square it, and y2 minus y1, and I square it, and that's what I'll end up at. So x2 minus x1, remember it's going to be 9 minus 0 squared plus y2 minus y1 will be 15 minus 4, and then squared. That'll come to 9 squared, which is 81. 15 minus 4 is 11 squared, which is 121. I could then just simply put this on the calculator. The square root of 81 plus 121 is 14.2 to 3 significant figures. And that's the answer for this here, 14.2. And it's now been applied. Let's suppose I have a line now that's going in the other direction. And the coordinates are given as such. So let's see if you can try this one. The coordinate at the top is -4 and 14. The coordinate at the bottom is 7 and 0. All right, see if you can find the length of this line where A is at the top and B is at the bottom. Press pause, try it. When you're done, press play. This is what I've tried at the moment. So first thing is, when I substitute into the formula, so AB, I'm going to call this x1, y1. I'm going to call this x2, y2. And it's going to be x2 first, subtracting x1 in the first bracket. So that's going to be 7 minus -4 squared plus 0 minus 14 squared. And then that will come to 7 minus -4 is 11. So that's 11 squared. Minus 14 squared is going to be a positive value, 196. Right, so that's 14 squared. So it's going to be plus 14 squared, like that. So that's where you're going to be adding it up. 11 squared is 121 plus 196. Putting that on the calculator comes to 317. And when you square root 317, you get 17.8 to 3 significant figures. Double check on the signs. Whenever you put it on the calculator, make sure that this over here is inside a bracket and it's not minus 14, because if it's minus 14, then it'll end up as a negative value and it'll produce an error. So make sure that that becomes a positive at that point. Okay. All right. Let's move on to the next one now. We want to find the equation of a line passing 2 points. So if you want to find the equation of a line passing 2 points, we can use the formula y minus y1 equals mx minus x1, where m is your gradient and there's a point x1, y1, which you have. All right, so let's look at an example of a question like this. Find the equation of the line passing 2 points, A 4, 2, and B -3, 5, let's say. The gradient that we find has its own formula, and the gradient formula is change in y over change in x, y2 minus y1 over x2 minus x1, given 2 points. So that's the first thing we would apply over here. We would make this one x1, y1, x2, y2, and let's get the m value that we need for our equation. So y2 is going to be 5 minus y1, which is 2, over x2, which is negative 3, minus 4, which is x1. And this comes to 3 over negative 7. So the gradient will equal negative 3 over 7. So now that I have that, I now need to substitute this into the formula. So step 1 would just be to get the gradient. Step 2 now is to use the gradient, and we're going to substitute m equals a negative 3 over 7 and one of the points, and you can choose this point that you want. It can be either 4, 2 or negative 3 and 5. So let's say I go with 4, 2, which is point A, into that equation. All right. So we got y minus y1 equals mx minus x1. M is going to be negative 3 over 7. X minus x1 is going to be 4, let's say. I chose that one to be it. And y1 is going to be 2. So y minus 2. I need to get it in the form which is y equals mx plus c. That's the standard form of a straight line. So I need to move the 2 over. That'll become plus 2. The negative 3 over 7 will multiply by x. Negative 3 times 4 will give you 12 over 7 plus 2 on the other side. So you end up with 12 over 7 plus 2, which is 26 over 7. And so therefore, from there, we're going to have y equals negative 3 over 7x plus 26 over 7. And now I have it in the correct form. We just added those two values over there. So 12 over 7 plus 2 over 7 got me 26 over 7. And now I'm done. I've got the equation of the straight line in 2 steps. All right, let's see if you can try the next one. Okay, so try this one. Find the equation of a line passing point A, negative 3, 4, and B, 7, 9. All right. Press pause when you're done, press play. Okay, so for this question here, the first thing I'm going to do is step 1. I'm going to find the gradient. The gradient is going to be given by taking y2 minus y1, so it's 9 minus 4 at the top, over x2 minus x1, but x1 is a negative, so negative plus becomes a plus because two negatives become a plus. It will look like this. So you got 7 minus minus 3, which is plus. 9 minus 4 is 5. 7 minus minus 3 is plus 3, so it becomes 10. In other words, the gradient is half. So now that I know that the gradient is half, I can go on to step 2 and substitute it into my formula. Y minus y1 equals m, which is half now, x minus x1, going straight into that equation, changing the m value. Between the two values, instead of dealing with a negative, I will rather use 7, 9. So I'm going to substitute b 7, 9 in there, where x1 will become 7, so it'll be half x minus 7, and y minus 9 equals half x minus 7 over 2, and then adding the 9 on the other side, keeping y alone on the left-hand side. We now have negative 7 over 2 plus 9. Negative 7 over 2 plus 9 is 11 over 2. And so we have y equals to half x plus 11 over 2. Negative 7 over 2 plus 9 will come to 11 over 2, giving me half x plus 11 over 2. I can also write this in decimal form, y equals 0.5x plus 5.5. And that's also fine. All right, let's check. So If I substitute the a value, I should get exactly the same equation, but let's make sure. Here we go. Let's test this. So if I go y minus, now I'm going to substitute negative 3 and 4, so it'll be y minus 4 equals m, which is half x minus, and here we have to be careful of the negative, so it'll be minus 3, and I've got to move the 4 across, so I'll end up with y equals to half x, and this is going to be half times multiplied by plus 3, which is plus 3 over 2. So that's plus 3 over 2, and then plus 4. So let's check that out. So what is 3 over 2? 3 divided by 2 plus 4, 11 over 2. So y equals to half x plus 11 over 2, and yeah, you can see the answers are exactly the same. All right. All right, so the next part now is basically parallel lines, okay? So if you're looking at parallel lines or lines that are parallel to other lines, so let's say I have a question. Remember, parallel lines, firstly, the gradients are the same, which means that if you have, for example, y equals 2x minus 4 and y equals 4x minus 5, those are not parallel because they don't have the same gradient. But if it was 2x minus 5, then yes, those two lines are parallel. They have exactly the same gradient of 2 in each case. Okay, so now looking at a quick question, I want to find a line parallel to y equals 3x minus 4, passing the point let's say 1, 2. So I want to find another line. So this line is a new line, not this one, another one. With the same gradient passing that point. So this is how we would do it. The first thing we do is we write the entire line with the same gradient because it's parallel, but just write plus c. And now we're going to attempt to find c by using the method of substituting the x value as 1 and the y value as 2. Which means this is going to become 2 equals 3 times 1 plus c. 2 minus 3 is negative 1. C equals negative 1, so y equals 3x minus 1. So what do I have now? I have a new line, which is parallel to the original line and passes through this point 1, 2. If I had to draw this line, I'll just quickly sketch each of these lines, roughly. So the one's going through negative 4, all right? So let's say it's going to be over here, and it's a positive value going like that. And the other one is parallel, but it's going through negative 1. So like that there. So those are the two parallel lines there. Okay, you try this one now. So I want to find a line which is parallel to y equals to 2x plus 6, passing the point, let's go negative 1 and 4. All right, press pause, give it a go. When you're done, press play. Okay, so what I'm going to do is what you notice is that this point actually lies on there, because if I make this negative 1, this becomes 4. So this is not going to be parallel. It'll be exactly the same equation. That's right. So let's change it up. Let's make it negative 4. Let's make it negative 1, negative 4. All right, try it now. And you should get a different solution. Try it. So yes, so this here, what we have is y equals 2x plus c, because it's exactly the same gradient. And when I substitute negative 1 in for x, All right, I'm going to substitute negative 4 in for y. That becomes negative 2, which I move over to become plus 2. And that becomes negative 2, so y equals 2x minus 2. Like that. Yeah, so that's the final answer there, line parallel. Let's have a look at the concept of perpendicular lines now. All right, so looking at now perpendicular lines, we have to apply exactly the same method, but one more step before that. When two lines are perpendicular, and let's say you know the gradient of this line. So this line is y equals to 2x plus 4. And you have some kind of point that is perpendicular. All right. Let's say we don't even have that coordinate. Let's say we want to find out what this line is. This is going to be y equals to the perpendicular gradient x plus some value c. Perpendicular meaning 90 degrees, right? So the two lines are 90 degrees and we want to find the new equation. What we have to do is we have to take the number 2 and we have to invert it and negate it, make it negative. And that becomes negative half. So therefore the new equation becomes y equals to negative half x plus some value c. And then if we're given a point that this lies on, let's say the point, there's some point on here, 1, 4, then I can substitute 4 in for y and 1 in for x, and that'll become 4 plus half equals c, which is 4.5, which is 9/2. So we end up with y equals to negative a half x plus 4.5 for this equation. In order to do this question, all I needed was a point, but I needed to take the gradient that was given and I needed to invert it and negate it, because the rule says the two gradients have to multiply to get negative 1. So if the one gradient is negative half, the other one is 2, then yes, it fulfills that rule. And that's the rule of perpendicular, is that the two gradients will multiply and the answer will always end up as negative 1. All right, let's see. I want you to find the equation of the line perpendicular to y equals to 3x minus 7, passing the point 0, 0. Let's say we're passing the origin. Okay. Remember, the concept of inverting any gradient is that if you have a gradient and you want to invert it, what you have to do is put 1 over it and then put a negative in front. And this becomes the perpendicular gradient every single time. Yeah. Okay. Give it a go. Try this question. When you press pause, when you're done, press play. Okay, let's have a look at this one. Here we go. So if I want to find the line perpendicular to this, it's going to be y equals to negative a third x plus some c value. And now I'm going to substitute x equal to 0 and y equal to 0. So that's actually y, 0 and x there. So we get 0 equals negative 1 over 3 times 0, which means that c ends up as 0. So therefore, the equation is simply 1 over 3x. That's it. Passing the origin. Negative 1 over 3x. Okay. Cool. So what have we done so far? We have covered from the start, we've done the midpoint of a line. We've done the length of a line. We've done the equation of a line passing 2 points. We've also done parallel lines as well as perpendicular lines. Okay. Let's look at now the concept of finding where do two lines meet. So if you want to find the point of intersection, find the point of intersection of two lines. You can solve it simultaneously, you can use elimination, or you can just equate them. And let's see how this works. Find the point of intersection of two lines. Okay, so let's go with an example. Find the point where the line y equals negative a third x plus 4 and y equals 3x minus 2 meet. Where would we find that? So the first thing I think we should do is equate them and solve it simultaneously. And this is basically the concept of simultaneous equations, which is applied here. So I could drop the y's and equate that and solve for x. So let's say I did that. Let's say I took negative 1 over 3x plus 4. Because they share the same y value, I can make them equal. And now we want to find out what would make x equal as well. So 1 over 3x minus 3x, negative 2 minus 4, negative 1 over 3 minus 3 comes to negative 10 over 3. X, and that's negative 6. I'm going to move the 3 over and multiply it. It'll become negative 18. And I'm going to divide by negative 10. And therefore, we get x equals to 18 over 10, which is 9 over 5. Once I found my x value, I can then substitute it back in. So this is step 1. And now step 2. I'm going to substitute x equals to 9 over 5 into any one of the two equations. I'm going to choose to substitute it into the second one because it doesn't have a negative and there's no fraction. Y equals to 3x minus 2, and x will become 9 over 5 minus 2. 3 times 9 is 27, so this gets me 27 over 5 minus 2. 27 minus 10 is 17, so 17 over 5. Y equals 17 over 5. And therefore, the point of intersection will be 9 over 5, 17 over 5. Using that same method now, try this next one. All right, find the point of intersection given the two lines, y equals to 2x minus 5, y equals to half x plus 10. Let's say negative half x plus 10. Okay. Press pause, try it. When you're done, press play.